So far, our journey through calculus has led us into an exploration of the derivative. Now it's time that we go the next step and look at the integral. That's another big topic in calculus. We start off with the derivative and then we look at the integral. But before I can define for you what an integral is, we need to think about these things called Riemann sums. So let me illustrate what a Riemann sum is and how we can use it. Let's suppose that we have this function, f of x equals x squared plus 1, on the interval 0 to 1. So we're looking at, this part of the curve right here, from 0 to 1. And let's suppose that we want to find out what is the bounded area underneath this curve and above the x-axis between 0 and 1. In other words, we want this area all in here. Well, so far we don't really have any tools to figure that out. I mean, we can calculate the area of a rectangle or a circle, trapezoid, things like that, but the area under the curve, that's a different thing. So let's see what we can do. Since we know how to find the area of rectangles, maybe we can use that bit of information to figure out, to at least get an estimate about what the area is under that curve. So let's think about using 5 rectangles to divide up this region and see if we can calculate what the area is. In other words, I'm going to make a rectangle here, just under that curve. I'll make another one here, and I'll do this with 5 rectangles. In other words, what I want to do, I want to calculate the area of each one of these rectangles, then add them together and say, okay, that's kind of an estimate for what's under this curve. Now you can see it's not exactly, because we have space here that these rectangles don't cover. So it's not going to be, the value that we get is not going, it's going to be less than the actual area. But anyway, so I've divided it into 5 rectangles, 1, 2, 3, 4, 5. And if I make sure all those rectangles are the same width, I would take 1 divided by 5, and let me call that delta x. So that's 1/5. So the width of each one of these rectangles is 1/5. Now let's look at this first rectangle. Now notice that I'm starting right here at the left end point. This rectangle is touching the curve on its left corner right here. So we're going to call this a left Riemann sum. And the area of that first rectangle would be the 1/5, the width here, times f of 0. See? F of 0. So that's height times width, right? Length times width. See? That would be the area of that first rectangle. And then the second rectangle, notice we were right here at 1/5. See, this is 0, 1/5, 2/5, 3/5, 4/5. See? Okay. So let's look at the area of that next one. The area of rectangle 2 is the height of f of 1/5 and the same width. We just made these rectangles all the same width. The third rectangle, see, here's 1/5, 2/5. Here's 2/5 right here. So we have f of 2/5 times the width. The fourth rectangle right here, f of 3/5, see, 3/5 times the width. And then finally the fifth rectangle right here. We've got the same 1/5 width, but now the height is f of 4/5. So look, we've divided this rectangle up into 5 equal parts. And we're going to say, okay, that's going to be an estimation of the area under that curve. So if we add up all these, if I add up all these areas right here, I get 1.24. Okay, so now notice this is, like I said, this is an underestimate, and I call this a left Riemann sum. See, because we've got this left hand, we're including the left endpoint. See, we're starting over here at the left, f of 0, 1/5, 2/5, 3/5, 4/5. Okay. Now let's look at what happens if we go the other way. In other words, instead of starting over here at the left, where the corner of the rectangle is touching the curve on the left, let's suppose we have this situation. We have the same number of rectangles, but now we have the corner of each rectangle is touching at the right. So now notice that we actually include the right endpoint. We include the 1. See? So I'm going to call this a right-hand sum. See? So now we still have the same width. Of course, we have 5 rectangles. We divide 1 up into 5 equal parts. So let's see what we have here. There is the first rectangle. Now notice it's not f of 0 now. It's f of 1/5, right? Because we're starting over here. F of 1/5 times 1/5. See? Notice that. We're not starting over here at 0. We're starting here. And then we have the second rectangle, f of 2/5, f of 3/5 for the third rectangle, 4/5, and finally f of 5/5. And of course 5/5 is 1, so f of 1 times 1/5. And if we add up all of those, we get 1.44. Now notice that this sum, if we add up all the areas of this rectangle, that's an overestimate of the area under the curve. Now here's what we have. We have that the true area is bigger than 1.24. And it's less than 1.44. So at least we've got to start there. We know, at first we didn't know what the area was. We didn't have any idea. Now we've kind of boxed it in, and we know the area is between 1.24 and 1.44. So we're off to a good start, and what we want to do to continue this is we want to say, well, how can I box in the area even more? How can I get a better estimate? But that's on another video.